Welcome to EDU World Space.
We are given that the nth partial sum of this entire series is given by the following formula here. And then we'd like to find an as well as the whole sum. So recall by definition, Sn is just the sum of the a's. And in this case, we're starting at 1 here. This index tells us where to start. And we just add all the way up to an. Now, on one hand, we'd like to find this an here. So one way to solve for this an is to notice that an is equal to Sn minus 1. Now, the way to see this, we know what Sn equals. We know what Sn minus 1 equals. And actually, I could go back to the previous line up here, and I could write Sn is all the way up to an minus 1, and I also add one more an there. So when I go ahead and subtract Sn minus 1, we'll go ahead and cancel all the a's all the way up into an minus 1, and then we're left over with an. So that verifies this equation over here. And now, since we have a formula for Sn, we could go ahead and use this. So we have 3 minus n over 2 to the n. This is for Sn. But then we also have minus and then Sn minus 1. So just replace all of the n's in the formula with n minus 1. And then this could be simplified. We could cancel the 3's, and then we have n minus 1 over 2 to the n minus 1 minus n over 2 to the n. And if you really want a common denominator there, you could go ahead and multiply top and bottom of this left term by 2. And then you have 2n minus 1 minus n over 2 to the n. So n minus 1 over 2 to the n. So finally, all that work, and that's to find the formula for an. That's the first part of this question. So a sub n is equal to n minus 1 divided by 2 to the nth power. Now we'll go ahead and do this last part is actually less work. Well, possibly less work here. So what we can do is write this infinite sum as a limit. So this sum, we could always pull out the limit. Let's say k goes to infinity, and then we only do the kth partial sum here. So in the parentheses right here, that's just equal to sk by definition. By definition, sk is the sum of the first k. And now we have a formula for the limit of sk. Well, we have a formula for sk here. So now we need to evaluate the limit of 3 minus n over 2 to the n. So let's go to the next page for this one. So for something like this, we technically do have this indeterminate form here. This is infinity over infinity. And so technically, let me use the letter x here, and I'll explain why in one moment. If you want to use L'Hopital's rule, then you need differentiable functions. And sequences are not differentiable because they're only defined in natural numbers, so not continuous, not differentiable. So here I'm just replacing n with x. So I have all real numbers. X could be any real number. And then for something like this, we can use L'Hopital's rule because we have infinity over infinity, as we pointed out. The derivative of the x is just 1. And then the derivative of the denominator is 2 to the x ln of 2. And then as I take the limit here, I get 1 over infinity. ln 2 is just a positive number. So this is just 0. So that tells us in the limit that n over 2n just goes to 0. And that the final answer in the limit, we have 3 minus 0 equals 3. And that was our formula for the entire sum of the series from 1 to infinity of an. And that's our final answer.